sir. Okay, good morning. So, myself Suresh Khumar, and I'm working as a senior engineer in Atkins Rallis, and mainly focusing on this HVDC projects for LG. So, main responsibilities, I am reviewing all the DC section equipments like converter, transformers, valves, reactors, so on, all DC scope.
DC scope of the converter stations.
Yes. So overall, I have 20 plus years experience in FACS and HVDC projects. Before I was with Hitachi Energy, then I worked with the engineering here. So I focused mainly fully on FACS and HVDC projects. Okay, so all your background from electrical engineering, correct?
Yes.
Okay, and you have a college fresh passed out. Or you have already some experience?
I have 2 years of experience.
2 years
ABB,
experience.
yes. But in instrumentation, not in power.
Okay.
Yeah, underground cables,
Okay.
connection between substations.
Okay.
For me, my own experience with the company for 1 year here.
Okay.
That's it.
Okay, so I just want to explain some first HVDC basics, okay? Then I will just go through the SLD and layout. Then if you have any question, we can talk later also. I think I am using my previous slides, what I did in the Hitachi Energy.
ABB, huh?
Okay, yes. I hope you already have a brief introduction about HVDC, correct? What is HVDC? So this is just a history picture. Like HVDC is invented by one scientist, Lam, in Sweden. So he is very early days. He discovered this technology and very long back. Maybe this HVDC is energized during 1953. First project. This is the first project between Gotland and Swedish mainland. So what is the voltage level? 150 kV using HVDC cable system and using cables, and length is 100 kilometer. So energization year is 1953. Okay. This is for just information purpose. I don't know if we will skip this ABB development and HVDC.
Yes. You was in electrification, huh?
Huh?
Electrification division, ABB.
I was working with this valve solution, HVDC. So I just want to explain the HVDC characteristics here. So why we need HVDC instead of AC transmission lines? Okay, we have AC transmission, we have DC transmission. Why we prefer DC transmission nowadays?
This losses.
Yeah, losses. AC is more conductors, more losses. Now DC is less, only two conductors, positive pole and negative pole,
Yes.
and losses is less. Apart this, we can able to transfer bulk power like 3000 megawatt, 4000 megawatt, 5000 megawatt from long distance. So current NG project, you know, correct? From it is transferring 3000 megawatt from Riyadh to Jeddah,
Yeah.
west. The other one is from 4000 megawatt from Riyadh to Kutmi, yes, Jeddah. So this is bulk power transmission and long distance, and it is more techno commercial effective than AC transmissions. And we can easily control the HVDC system. AC system, it is very tough. We can't able to control, but DC, it is independent of the phase angles of the network, so it is easy to control.
Why? How?
I'll show you in the next
Okay.
slides, okay? And so this point is clear, right? It can reduce the total cost for long distance power transmission with overhead lines and cables. And connect AC system asynchronously. You know the asynchronous, correct?
Different
frequency, different voltage, different phase angle. So by using this HVDC, we can connect asynchronous system. And also fast and accurate control of power flow. So we can easily control power flow using the HVDC systems. I will show you that in the next slides. So this is just to compare the double circuit AC with DC lines. So this is 2000 megawatt, and see only the circuit is very simple. But AC is more lines, more circuits, and double circuit is required to transfer this 2000 megawatt. Okay. And here, so this is just to compare when we are preferring the AC transmission, when we go with DC transmission. Okay. So it is investment versus distance. Like this is we call critical distance. Yeah, this critical distance. So after this critical distance, maybe DC is more benefit than the AC. Because if you see here, total AC cost is more. For example, this critical distance like now 800 kilometer or 600 kilometer. If power transfer from one area to another area, the distance is more than 600 kilometer, the best way is DC transmission compared to AC. That is called a critical distance. Okay. The disadvantage is here DC terminal cost is more, like station, more equipments, valves, reactors, transformers, so many equipments. But AC terminal cost is less because of absence of valves and other equipments. But if long run, if you see the line cost with the series combination and this losses, so up to critical distance the AC transmission is working. After this the DC total cost is less compared to AC.
The critical distance different from one country to another?
That is mostly like 600 kilometer to 800 kilometer. But that it depends upon the various parameters here. Cost of land, cost of material. From country to country it will be differ, right? But the range will be like 600 kilometer to 800 kilometer. So this is just SLD of typical converter station. Okay. I think the first part here is ACR. So all this like harmonic filters and the incoming supply from the AC substation, everything will connect here. Disconnectors, earthing switches, CVTs, all in this AC section. By the way, this is for a classic HVDC classic LCC project. I'm just showing as an example. Okay. And this is for converter transformers. Then this is valve, and this is DC side, DC filter and everything. So here you know the converter transformer, it is connecting the AC phases to the valves. And you know the filters, correct? Harmonic filters. Harmonics, it is multiples of the other frequencies. Like fundamental frequency 60 Hz.
Yeah.
If you have the one double, what is even harmonics and this odd harmonics like second harmonics 120, 180, like multiples of frequency is called harmonics. Okay. So we need some filters to suppress the harmonics and to protect the network.
It's similar to before you said asynchronization. Similar to asynchronization.
Synchronization.
Harmonic. Similar to asynchronization. Similar.
Maybe this is why it is coming. We have these valves, correct? Valves produce the harmonics. So these harmonics we need to suppress here. Otherwise, the harmonics will flow from here to the network grid. So all the harmonics produced by these valves will be suppressed here.
I hear that all power electronics in general they produce this harmonics.
Hmm?
All power
Yes,
electronics
yes,
in general they
correct.
produce this.
All power electronics devices will produce.
Even the one used at homes.
Yeah,
Sometimes they
yes,
produce harmonics.
yes. Wherever that natural frequency of the waveform will disturb by chopping or something, then harmonics will produce.
Yeah.
So the filter will select multiple of the frequency or? will-
Yes, yes. This is for 11th, means 11th frequency will be filtered here.
Okay.
13th means 13th into 60 Hz. That frequency will be filtered here.
Okay.
High pass, all other high pass filters filtered.
The low pass will not pass.
Low pass, it is not
Yes.
not that much magnitude, because this is 12 pulse converter, correct? 12 pulse converter. So 12 pulse converter normally generate 11th and half 13th harmonics predominant. Lesser order harmonics, it won't that much magnitude.
Why do we use this high pass filter?
Which one?
High pass filter.
High pass filter is like more 24th, 36th, higher end filters, higher order filters. Whatever higher order harmonics will be suppressed in the high pass filter. That is what we see the monopole, one pole, single pole. I will explain what is monopole and bipole and all in after some slides. Okay, this is bipole converter station. So bipole, it is exact replica, same one pole, and this is the second pole line. This is that same thing. For example, plus or minus 500 means this is plus 500 and this is minus 500. This is just for basics only, okay? Because in our project here, only Saudi Egypt is this technology. We call it LCC or CSE based
VSC.
Saudi Egypt project. But this NG project, what we are having, VSC based.
What is the difference between VSC and this LCC in terms of diagram?
In terms of diagram, we
It
don't
will be
have
filtered,
we
right?
don't have filters here in VSC.
We don't have filters.
We don't have filters. That is the beauty of VSC technology. Okay. And instead of thyristors, we have IGBTs here. This is transformer. It is normal, look like power transformer only. But LCC, this is something very big transformer called a converter transformer, because it is has different windings inside, and the lot of very big bushings come to give star to star and star to delta phase shift. Okay, this is little different, and the rest of the thing is same. Only IGBT is different, and transformer it is different little bit, and we have the phase reactor here, connected here or here. And that's, I will show you.
No.
Just to understand, this is the Saudi Egypt configuration. Okay, I will show you this our present project in later slides. Okay. So this is the different technologies for HVDC. First is called classic or line commutated converters. This one is called HVDC light or force commutated converters. This is their Hitachi energy terminology. Okay, Siemens called is different, HVDC plus or something different. But in general, we call line commutated converter or VSC commutated converters. Okay. The main difference here is the VSC is more advantage than these two, because this is very large because of the reactive power requirements. And I will come on by one. Power of control. So here we can only control the active power, not the reactive power. But because
يسوي تردد زي الأرض هذا تردد.
لا هو عشان اتوقع ان الليفت يعني مثلا الليفت من 60.
okay, so these both technology is LCC based and both only control active power, not reactive power. But light control both active and reactive power, because IGBT we can turn on or turn off, both we can do. But thyristor we can only turn on.
Zero crossing, yes.
Yes, it will that is called line commutation. Line commutation means in zero crossings only thyristor can be able to turn off. Okay.
So it depends on the network.
Yes, yes. So this all required some demanding reactive power from the network for commutation purpose, because it won't do the self commutation thyristors. Okay.
So at all times, for LCC, the thyristor will be working until zero crossings or to turn off.
Yeah, until turn on, then we can release this triggering pulses.
Yes.
The controller is there, no? That can stop block the thyristors also. In that we can off it. Otherwise turn off and we can't, current won't be bidirectional in the thyristor. It is always unidirectional thyristor. Okay?
By choosing the firing angle, right?
Yes, yes.
Okay. So we can turn it off or not? This is
We can turn it off
no
by
problem.
using removing the pulses, triggering pulses to the gate.
Yeah. So
Or line commutation, no? Whenever the 0 is come, that time only the thyristor will turn off.
okay.
And we have the firing signal to the gate. You know the VA characteristic of the thyristor, right?
What?
The characteristics, VA characteristics of the
I
thyristor.
remember it briefly, to be honest.
We can reduce the voltage in some extent to turn off the thyristor, or by removing the gate pulse, we can turn off the thyristor.
Okay.
We can see. Or you
I
can-
remember something about the voltage entering the thyristor and the angle.
Yes.
Cosine theta, something cosine
Yes,
theta.
yes.
And we can adjust these both to reflect the output.
Yeah.
That's what I remember, to be honest, from my university years.
Okay. We'll see later also. So I don't know this converters demanding reactive power for a commutation purpose. Okay. That's why a lot of filters it is selected. More filters are installed, and it will give the reactive power and it will filter the harmonics also. Reactive power balanced by shunt band switching. So shunt band means I shown some filters, correct? That is supplying reactive power and also filtering the harmonics. And this is minimum system short circuit capacity of twice rated power. So this VSC is only to be connected in the strong networks. Like where the short circuit ratio is more, that is called strong network. Short circuit ratio is less, that is called weak network. So wherever weak network, VSC is more. VSC is the preferable technology.
So LCC depends on the network.
Network. If strong network and SCR ratio is more than 2, then we will prefer this one. If SCR ratio is equal, we will prefer capacitor commutator. This is another technology of LCC only. If SCR is very less, maybe 1 or 0.5 or less than, we will go with VSC technology. Okay. So here, this is capacitor commutator means capacitor is connected in series between the transformer and valves. That is called capacitor commutator converters. And here, this HVDC light, we called it force commutator or voltage source converter. It will give both active and reactive power control and easy to voltage regulation and modular and expandable, black start capability and no short circuit. Black start, we have a very good future of the VSC technology. So, but we don't have in LCC. That's why this our current projects also we have this black start future for NG HVDC projects. So if complete network is blackout due to some fault, then the healthy HVDC station will feed power and energize that black network.
Black start?
Yeah.
Black start?
Yeah, black start capability. Black start means if one network is out, completely no
Yeah.
power due to some major issues.
From one
Okay.
side?
Huh?
From one side, for example?
Yeah, one side.
Like this? for example.
Yes, yes.
Right side, yeah.
Yes. The other connector station, okay, it will feed power, but this is completely
The
blackout.
converter station from this side.
Yes, yes,
Okay?
yes. This complete blackout, the only auxiliary powers, no, like valves, cooling system and all, that will be powered up by the diesel generator or something, external batteries like that.
Okay.
Once a small power is given to the valve will functional and it will get that power from and it will feed to the network. Normally this is the black start is restoration of the faulty network or blackout network. Okay. These is a different transmission modes. We have monopole, ground return. So both stations are grounded. So the power is transferred with one pole only.
How is this possible? I heard about this a lot, but I couldn't comprehend it. Because the current need the return path. So how?
The ground is acting as a return path. That's why ground at both sides. Ground is acting as a return path here.
Okay, just the ground.
Just ground. Because power is coming and here, it is closing here, then flowing here. Ground is a return path. But this has many disadvantages, like sometimes grounding of is not restricted due to it will give some
Soil.
yes, soil or some leakage current in the ground. It will impact in the neighborhood or something. Some communication disturbances, lot of things are there. Even sea return also not acceptable in ground because it will impact the what it called in beings, living beings in the sea. Sometimes leakage current will flow, ground return current, something. So it is not that much preferable. And monopole metallic return. Metallic return means one single other conductor will connect here. And ground is happening in only one this side.
This is DMR, right? DMR?
Yeah, you can call the DMR also. Metallic return, dedicated metallic return. DMR is dedicated metallic return. Yes. And here 12 pulse group, and here we have the midpoint grounded configuration. So this is in between 6 pulse converter, 6 pulse converter. We are doing grounding here, and only one station side. So all this monopole limited to up to 1500 megawatt or recently now 2000 megawatt only. So it is limited transfer capacity. But if you go with the bipole, this is what we used now in the NG project. So all this is one bipole. This is one pole and this is the other pole. And midpoint is grounded. And this is back-to-back configuration, which is for to connect asynchronous network. Like this is 50 Hz network and that is 60 Hz network. And we can transfer anything.
But this is AC
Like-
connection, right? AC connection.
Without DC line, AC only.
AC.
Both side AC. This is rectifier and this is inverter. With only the line is just short in the same station itself.
I hear this.
There is no transmission
I
line.
hear this is used when connecting two countries that are very near each other,
Yeah.
but have different frequencies. For
Yes.
example, between Saudi Arabia and Bahrain, for example.
Yes, of course. You can install a converter station in only one place. You can get Saudi Arabia from one station power, like 50x or 60x. Then Bahrain may be different, correct? 50x power. So you can transfer in both countries, vice versa.
Yeah.
So.
So here we don't have two compressor stations, right?
Back.
That's back to back.
Yeah, back to back we don't have, only one station. Only one station. Yes.
Between the middle, between the two
Yes,
countries, or
yes.
two.
That's correct. Yes. And yeah, maybe this will be located in Saudi Arabia or this will be located in Bahrain. The lines, this will be AC lines and only one station.
Yeah.
This is what I told. No, this is the control. Control is very accurate and because this is the AC. AC we have the network U1 sine alpha 1 and network 2. The formula for power transfer is U1 into by X transmission line reactance sine alpha minus 1 alpha 2. Okay, this is the phase angle between the two networks. Okay, but here we don't have this alpha here. We are just converting this AC to DC. So power is mainly depends upon the UDC into IDC. So there is no angles, phase angles of the network here. So that's why the power flow control is very easy. power flow independent from system angles. And this can be due to absence of this phase angles of the network. We can control the very fast and accurate control of power flow.
So the control is more easy because of this.
This is absence of this network angles, correct? It is only depend upon this voltage only now, UDC and IDC.
I hear that for the same conductor, now the reactance and the sign difference of the angle will limit the power transfer by a certain factor, right? But for the
You mean
HVDC,
next-
it's directly current.
Yeah, yes. Here it is depends upon this one also, correct? But here there is no depends upon the transmission line reactance also. That's correct. So you know this HVDC will transfer power both directional, rectifier to inverter or inverter to rectifier. Okay. So how we are doing? This is the power direction. First rectifier. So 100 volt and here inverter. So higher voltage to lower voltage current flow is flowing. Okay. This is thyristor's unidirectional device. Always will flow like this only. And by controlling angle, the firing angle control, we will change this voltage up to alpha 0 to 90, the positive voltage. Then if we increase the voltage 90 above, then it will come as a negative. So the power flow direction will be like this for rectifier, one side rectifier to inverter. Then I want to transfer reversal power. Then I can't change the direction of the current here, because this is the thyristor always flow in unidirectional only. So I can change the voltage polarity here. Like the voltage polarity is changing by the angle change, firing angle change of here. So I will act this one as a rectifier and this one is a inverter. Then I will make this is a minus 100 volt by changing firing angle. Then I will make it minus 99 volt. So current direction is like this only. So maximum voltage to minimum voltage. But if you see that power, this is 100 watt and 99 watt. So power reversal will be happening.
For VSC, it is bidirectional.
Yeah. VSC
So
also
no need to
bidirectional,
change
but
the-
no need to change the VSC is different. We can IGBT can turn on and turn off. Okay. So we can change the direction directly in the. No need to change that voltage here.
Yes.
Both the technology we can do the power reversal. That is the record. HVDC need to be transferred from here to here and here to here.
The reversing,
That is the record.
the reversing process, how it will happen here?
Which one?
Manually, automatically, how it will, the reversing,
Reversing.
yeah, how it will happen, manually?
No, everything will be controlled. HVDC controller is there.
Yeah.
That will take care what is the more need to be power reversal. It will get the command and it immediately act very quickly. So okay, this station need to be act as rectifier. Okay, I will change the firing pulse like this. Okay, make it as rectifier. Increase this voltage like that. Everything in the fast control.
Like it's يعني automatic or
Automatic.
from control room or something.
Yes,
like
yes,
that?
control. So in control room we have this operators, correct? HMI system operators are there. They have all the commands. What can do? What is the normal power direction? When it to be changed? Even it can be controlled in the remote control center also. Regional control center, national control center also. From that also we can do.
But here, why is the direction left from the right side?
Hmm.
It's opposite to the thyristor.
Why?
The current direction is opposite to the thyristor direction. Thyristor is going down and
Okay, this is the current direction. Okay. Thyristor is flowing one unidirectional direction.
Okay, what's this arrow in the service?
This arrow,
No.
this arrow,
No, left.
which one?
And then
Near
inverter,
the block of the
inverter side.
Here.
No, the inverter side. The inverter side in the first.
Inverter
See
side.
that there is a block? Yes.
This one.
Yes.
This is the telling us unidirectional. Thyristor is unidirectional.
Also for inverter
From
side.
anode to cathode, correct?
Okay.
Always it will flow like that.
How about the second one?
The inverter side.
Yeah, the other side.
Oh, this is okay.
Mistake.
Yeah, this is mistake.
Yes, has to be.
Always it will flow and it will flow. It will like that. This is maybe it.
Yes.
That's correct. That's wrong.
Same.
Yeah, yes. But you know, thyristor is a unidirectional current. Yes. We can't change the current direction as the thyristor. Only we can change the polarity of the thyristor.
The diode.
Yes.
It's a diode that it's all right.
Similar
Yeah.
to that.
Similar to diode. It's unidirectional only. Kind of
Yeah.
like conductor, no one way.
Yes. This is just show how look like this corridor line towers and all like 2000 megawatt like this and 400 only took huge right of way lands. So tower and OHTF equipments is more in the AC transmission line compared to DC.
Towers for the HVDC is always monopole.
HVDC? No, it can be monopole, it can be bipole, any configuration. Some countries no need to transfer bulk power. They very small country, maybe they need only 1000 megawatt is enough. They will build only monopole configuration. Any configuration, monopole is the bipole. Is the,
البور.
I have a question also for the back-to-back converter. This will convert AC to DC?
yes, of course.
This
The purpose of this. Okay,
Yeah.
I'll show you.
I see this 1000 megawatts. It will be AC or DC coming this side?
See, this is the converter.
Yes.
This is rectifier, this is inverter.
Okay.
So AC is coming, converter as DC, flow inverter and AC.
AC.
With the same
Yes.
station.
Same like that.
Okay.
This station can act as rectifier or inverter, this also can act as rectifier.
And this is two converters together.
Yeah, together in one station.
Okay.
So this is back to back means back to back we are connecting.
Okay.
No DC transmission line, no
Okay.
lines at all.
So the only
Just to get a different frequency network like 60 Hz and 50 Hz or something.
Isn't this more efficient than you have transmission lines?
Depends on
Normally this is very less, 1000 megawatt only.
Okay.
If you want more power, you need to transfer by
Transmit, okay.
Now China is transferring now. This is 9,000 megawatt, 10,000,
So engineer,
1,100 kV.
for example, now for any of these projects,
Mm.
if we're gonna move instead of 3,000 maybe for this COA, WOA,
Mm.
if we are gonna move 1,000 for example,
Mm.
we shall go with AC.
Again depends on this
Distance.
network distance. The
For
critical
example, if it
distance.
is long distance, should you go
Long
by
distance, we need to go with the HVDC only.
HVDC? but-
So even with low power, if we have different, if we have a lot of distance, we need to still we're gonna go with the HVDC.
HVS also okay, but there is a lot of factors is there. No, HVDC we need it is more controllable.
Power loss.
Okay,
Power loss.
power losses is less.
Like I'm going to the direction where we gonna use this back to back exactly.
Back to back.
Yeah.
Just simple.
Fixed frequency.
When if you want to asynchronous networks to be connected, like now there is one proposal from Saudi Arabia to
To
Jordan.
Jordan.
Jordan is different frequency and Saudi Arabia is a different
Jordan.
frequency. They are planning to build one HVDC using back to back.
Okay, if the capacity is below 3,000, let's say
Two thou-
1,000 megawatt.
Yeah,
okay?
1,000 very
One-
less months, they will go with this configuration.
Not by Bible.
Or,
No need for Bible, right?
no need bipolar.
Okay.
إذا كانت أقل من 2,000
So they are going to synchronize the network without any large power transfer, right?
Hmm?
Without any large power
كل
transfer.
البروجكت كان بايبول احنا
They are
نستعمل
going to connect Jordan and Saudi Arabia, for example. But they don't have
لا هذا مين بايبول مونوبول
like the capacity to move
بايبول
other power
24
compared to the other.
هذا كل البروجكتس اللي عندنا بايبول عادي.
If we are going to propose
Two-
connecting
two-
KSA to
two
Jordan,
poles.
for example,
Yes.
they are
Two-
asynchronous
two,
to each other,
Yes.
different frequencies.
Yes.
If we introduce back to back, we're going to limit ourselves to certain power, right? Not similar to the other
Yeah,
options.
yeah, yeah.
بايبول
The project in Saudi Jordan, maybe I can say
داخل البيبول هو
1,000 megawatt.
converter
They are
AC.
connecting two phases, two back to back.
لا
convertation.
1,000
هذا
back to back normally it is
نتكلم
less.
عن
You can't
transmission line.
transfer.
How about the distance?
Then this converter station will be very big. Right?
How is it- how about the distance?
Distance, we can AC distance, AC lines only, no?
Yes.
Distance, no issues.
Yes, so we should also keep distance in mind because Saudi Arabia and Jordan, they're not far from each other.
Yeah, that's why.
They're
That's why.
not
If
like
too much far,
not 200
if
kilometers.
too much far, then absolutely they will go with the HVDC only, with the bipole.
Yeah.
It's very short distance, so they plan with okay AC lines, but back to back because of asynchronous.
Can you explain the bipole, the difference between bipole and monopole? What's the process of bipole?
This is the double of that circuit.
Yeah.
If you multiply into 2, this will come. That's it. Here the rating is very less, 1,500 megawatt. But here you can go with 3,000
No,
megawatt.
I mean the
And one more thing. If anything fails here, you lost complete power. But bipole, if anything failed here, then you will connect with monopole. Reliability is there. Still you can get some half of the power transfer between the two networks.
I mean the word bipole. What does it mean? What's the process of bipole?
Bipole means,
Transmission.
bi means two pole, right? This is a plus 500 kV, minus 500 kV. Two poles. This one pole and this one pole.
Transmission system.
Yes. For example, 3,000 megawatt. From here to 3,000 megawatt will flow. This pole will deliver 1,500 megawatt. This pole will deliver 1,500. So 1,500, 1,500, 3,000 will flow and complete like this. For example, any failure here, I will disconnect this one. I will connect only this. I will transfer 1,500 megawatt to other network.
half of the
Yeah, reliability is more here.
And there is always will be an extra bipole
Yes, extra pole is there.
for
All project will go with the bipole. Why? More power will be transmitted. Reliability is more.
reliable.
So no need to worry blackouts and all.
Yeah.
So one pole will be still trans.
Here is the same as this our projects, but with metallic return.
Yeah, all
not
ours
ground.
are yes metallic return. Not grounded. Here it will connect one this one metallic return will connect for our projects. All.
Yeah, monopole only one transmission line.
Yeah, monopole only. One or metallic return also there or ground return also there. But people nowadays it is not preferable this because of less rated power. All countries are going with this now.
Okay. And with monopole, it's more reliable, more capacity.
Yeah, more capacity. Yes.
But,
Monopole is less and
less
some
efficient.
disadvantages are there.
Okay.
This ground return and all some countries is prohibited. This is just to show AC transmission require large corridors like this. So large area is required if
Large
AC
large
transmission. But if you go with the DC line, so you can save a lot of land here. And if you go with even
هذه تخفف القيمة.
if you go with the HVDC cable, there is no need of tower, correct? Underground cables. are there.
okay.
So it is more environmental friendly technology, HVDC. This is for losses across the transmission distance. So up to this some distance, I think the AC line losses is more after this, maybe 400 kilometer or 500 kilometer. But terminal losses is more in here, this one. AC and DC is here.
Initial cost or?
No losses.
Losses. This is for losses.
Okay.
So after some distance, I think DC is very less losses compared to. Sorry, this is.
This is
Yeah, this DC is
Zero.
losses compared to AC losses. I think losses in reality like this, right? We have each transmission line, we have resistance, inductance and capacitance are there in the transmission lines.
Yes.
So there are all the losses are there. Resistive losses, inductive losses, capacitive losses is there. Okay?
which is
Based on the frequency.
reactive.
Yes. But in DC, if in DC line, we don't have this, sorry, all inductor capacitors are cancel out it. Only resistor is making the losses, current losses. So
The
that is the
cover
reason.
loss.
Hmm?
The cover loss itself.
Yes.
The material itself.
Yes. So that is the way we have less losses in the DC system. So this is a little advantages why we go with the HVDC for interconnections. I think exact power flow control is there because the independent angle is not dependent here. And systems maintain their autonomy. Like HVDC as working act as a firewall. This AC network disturbance won't travel and come out this side because HVDC is act as a block. Okay. So it has maintained their own autonomy, like 58 system, 58 and 68 system, 68. Only
Isolation?
power will be transfer CS, but not the.
Isolation, you mean?
Yes, yes.
Between DC and AC or frequency also?
All the complete AC network will be their system characteristics not travel to the other side.
Between the two grids.
Yeah, two grids.
في مرة ثانية ولا
صوت
كم تخليه؟
نص ساعة نص ساعة.
بديت مرة
تو
ثانية
بدأ تو
يعني.
إيه.
اوكي sorry.
And also this any disturbances it won't travel to each system because HVDC it is blocking any faults, it won't be travel to the other side of the road. Okay. And efficient use of generating capacity because it will reduce the losses. But AC it has more losses. So whatever DC it has less losses. So more generating capacity can be utilized from rectifier to inverter or
And loss also less trips
yeah.
in the generator side.
Yes.
Okay.
And stability control. So does HVDC having more this control algorithms and controllers, it will give the better stability for the both the networks. And no increase in short circuit currents. So we have this short circuit limitation, nothing, no issues in the HVDC system. Environmental impact, so you see all these corridors and the big corridors are not recovered. And low losses for long distance transmissions and lower investments if the critical distance is exceeded.
What the
This is
difference-
just two basics of HVDC only, okay?
I have a question for,
Yeah,
for
yeah.
the transmission line.
Yeah.
What's the difference between HTL and UGC? يعني HVDC. When will we use HTL? When will we use UGC? According to the right of way. يعني?
You mean underground cable and?
Yes.
Okay.
HTL.
Or HVDC.
HVDC.
Mm-hmm.
They are the same.
Yeah, that's
Same
correct. If sometimes like two countries and separated by the sea,
Okay.
then we need to use the underground
Use-
cable.
use
Like Saudi Egypt,
Egypt,
it
oh.
is separated. There is submarine cable is there. Some countries where it is distance is very short, they will go with the UGC.
UGC.
underground.
So in general,
Mostly the LCC,
So
the
it's-
current source or LCC, which OH cable.
LCC
Because it's
only
more
HT.
power, yes.
Oh.
VAC normally they go with cables.
Both,
Because
also
VAC light, it is less power only, 1000 megawatt. And voltage also sometimes 400 volt, 500 volt only. Cable we have limitation. We have a DC cable up to, I don't know, now it is plus or minus 550 kV I think. Or 600 kV also available. But before and all it is 380 kV only. DC cables available. So those limitations. So these are the same thing repeating again. Reasons for IP preferring HVDC over HVAC.
No, in general we prefer HDL, right? In general.
Generally?
In general,
Hmm.
we prefer HDL.
Yeah.
I think it will cost less as well, right?
Yes.
It will cost less.
For HDL?
Yeah.
Mm,
Because for the
Okay, so-
ground you need like
So-
insulation.
But cable cost is more. Excavation and land
Yeah, that's
roads
right.
and all more. Normally these cables they prefer with short distance transmission only, like maybe 500 kilometer, 600, 700 kilometer they will go with underground cable. If more than 1000 kilometer, ultimately they will go with the
Also, if the connection is around like cities or something, they need to go.
Yeah, infield inside cities, they can't able to transfer with this OHTL, correct?
But-
That time they will go with the cables.
But usually-
city infield and all, that distance is very less, correct?
Yeah.
One region to other region. Not
And usually these interconnections for between countries are done like at desert levels or sea levels, so it's
Yeah.
away from the
all this is will be some too far, correct? This generating stations and all very far.
Like this project
from
is
the
very far from I think any big
Hmm?
cities or something.
Which?
These projects.
Hmm.
Avoid cities.
Yeah, it will not cross any cities or something.
These two, correct?
Major cities, yes, these two projects.
Yeah. So the main purpose is to transfer bulk power to one region to other region. The length also more, right? This is 1000 kilometers.
Yes, for
1,000,
yes.
1000
For
kilometers,
west.
1700 kilometers, something like that. West is something less, I think, 800 kilometers, I think.
900.
800, 900 kilometers.
About the effects that's in the AC, there is like corona effects. And there's
Yeah, of course.
HVDC, no?
No, because it is DC conductor, right? And AC is introducing that corona effect. Outer layer won't be
Yes.
transferable, only the inner layer. The
Yes.
cross section area of the will be reduced.
Yes.
So higher losses also there due to corona effect, and the transfer current will be also less. But the DC it is more.
What about the skin effect in the UGC?
Skin effect in the UGC.
Yeah, there is in the UGC something we call the missing calculation. In the UGC, during AC
Mm.
projects, DC project has the same yani effect.
I'm
Between
not sure.
cables,
The
distance.
cables I need to check. I'll come back to you.
No worries.
UGC
I
cables.
also heard that as part of the scope for the contractor for this project,
Mm.
he has to do like a corona losses study. I don't know. Is it like applicable to
Corona losses study
Yeah.
for which project?
These two projects.
These two projects.
Yeah.
To check which is the best transmission, like AC or DC.
No, I don't know. Maybe for HVDC.
But
I saw it in the BTS.
Mm-hmm.
corona depends on electromagnetic flowmeter. Electromagnetic, I mean electromagnetic, right? Because corona in the outer or on the surface there will be current because of the electromagnetic caused by the inner. let's
Yes.
say,
Yes.
current, right?
Yeah.
So in DC we don't have this.
Yeah, we don't have that.
كورونا ما في ابدا في الدي سي صفر ولا نسبه قليله؟
DC is normally the straight, correct? Not alternating.
Yes.
It won't create that
Electron-
layer in
yes.
that outer layer. That
Yes.
charges in the
Induced
outer layer.
current.
Yes.
So we don't have any corona effect
Yes, no.
in HVDC.
يعني it's zero or يعني margin error يعني 5%.
I think it is mostly nullable.
يعني zero.
Yes. Yes. Okay, so maybe I will get to show you the SLD or is it I know. Okay, I want to show you SLD and layout. So maybe next session we'll take it because I need to have some meeting also now.
Okay.
1 hour
No.
session today.
Sure.
We will take it next session, SLD and layout of this project.
Okay.
Okay.
And also I can give more detail about HVDC.
Components.
Hmm?
Let's say components.
Yeah, I'll show you components also.
If you could share the slides.
The slides?
Yes.
Okay, I'll show you. Okay. Viewable? It's okay? You can see?
Yes. Not very good.
So this is positive pole and negative pole, okay? So here from the AC station, the power is coming through the cables, okay, from bay, GS bay, okay? And it is coming to the cable sitting end here. And this is called a charging resistor circuit. Charging resistor circuit.
Charging.
Resistor. This is resistor.
Resisting.
Okay. This is normally during energization time only it will work.
Okay.
To charge this
DC.
capacitors. These capacitors. First, these capacitors will be charged through this resistor. Okay. Then it will cut off. This will be
How much?
on.
Oh,
So this
low
bypass
circuit.
AC circuit will on.
Why do
So
you
this-
want to charge the capacitors? Or is it like something?
We use it as batteries or?
Yeah, we need initially to charge these capacitors to feed this voltage to the valves.
No, this is for IGBTs, right? Not for the.
Yeah, this is IGBT valves only. This is the charging capacitors, okay? So this charging capacitor, it will only provide during the energization time to charge the valve capacitors.
Okay.
Then this AC circuit breaker will on, this will be bypassed by on switch on. Okay? And this is the CVT. And this is the filter capacitor. This is very small rated filter capacitor. And arrestor. All this connected near to that interface transformer. This is interface transformer.
I have a question.
I just show you the components, then I will give the. Yeah.
Okay. Okay. If you want to go.
Yeah, no issue. Tell me.
Because this transformer,
Hmm.
I didn't get the idea behind it, to be honest.
What idea means?
It's 380 kV
Mhm.
AC to 290 now, 0.88 kilowatt. What do we get from this transformation?
See,
What
this
do we need to
transformer is to
do?
connect the AC to valves.
Yes.
It is connecting us from AC system to the valves only. So this is phase, so how much? 380 by root 3. So how much it is? 230 kV. 230 kV to, this is 290.88 kV. Okay? So we have each phase one transformer. Each phases will connect like this. This is one positive ohm, this is negative ohm, okay? Like 6 bulbs, how it is that? Like this now. Transformer. 6 pulse converter, okay? Okay, so this is how much each phase transformer, converter transformer. This is main purpose is connect the AC phases to the each valve arm. This is 6 pulse, this one valve, this one. Positive ohm, negative ohm, okay? Plus 500, and this is 0. This is pole 1, and same like this is DC lines, okay? Here also same thing.
يعني this is not power transformer, not يعني step up step down, only for connection AC to DC.
This is step up only, no. This is how much this is. 380 by root 3. approximately 230, correct? And this is 290.88. Okay, 290.88 kV side to side, 290.88 kV. The rating is how much? 566.7 MVA. 566. So total 1500. So this pole is transferring 1500 megawatt. And this another pole also transferring 1500 megawatt. So total 3000 megawatt will go to the DC side. So transformer is acting as a connection between the AC to the valves here. This is normal power transformer only.
It does
Like,
step-
but only
step
the
down?
bushings will be different.
Here, step down.
This one,
Yeah.
230 kV to 290.8 step up transformer.
Step up. Oh.
Because why this question has been raised? Because why don't I just connect from 380 grid to the valve direct? That's it. Why do I need to bring the big transformer, put it there, just to raise the voltage? Maybe just now how many 60 volts only, 60 kilovolts.
No. Then how you will be acting as in reverse mode? How it will be this one?
عشان السيستم عشان يربط 380 يرجعها اذا بغى كذا يرجع كذا.
Okay, but we
Transformer is normally.
from my understanding, we can control the IGBTs to give the whatever voltage we want based on the power electronics. So even at the reverse, when we get a feed from, for example, from Jeddah to Riyadh, we can control from there to receive 380 there and connect it directly. But I also heard something that this transformer is used to isolate between AC and DC side.
ممكن.
This transformer? Yeah, normally transformer will give as the isolation, correct? Isolation. Electrically connected, mechanically separated, correct?
Exactly.
Isolation, yeah. You know, the normal purpose of the transformer required for the any transmission.
Because this is the normal, the voltage transformation is not like a common one. Between 230 kilovolts and 290 approximately.
Yeah, of course. This is not required to just step up and to get this this voltage. No.
Yes, this is my question. Like the first thing that came to my mind, do we need a certain voltage to be near 500 for the IGBTs to work? But I asked too many my colleagues, they said no, this is only for isolation. So that's why I wanted to ask you, what's the exact benefit of this transformer?
Yeah, transformation it is providing the isolation purpose only and to transfer the power and to connect the AC phases to the valves to make that connection arrangement.
Because
Not to-
the primary side and the secondary side are both AC, so we're connecting AC directly to the valves.
Yes.
There's no question about this.
Yes.
But does this voltage difference like make a difference to the IGBT or not? I don't know, 230 or 290 or 380, does it make a difference?
You mean this voltage?
Yes, voltage coming to the valves.
This voltage is depends upon that they will do the calculation for the valves. How many valves is required to this valve normally act as a switch to transfer this voltage to the DC only.
Yeah.
It acts as a
But
switch.
now we are gonna move 500 kilovolts along this DC, right?
Yes, yes.
So do we need the input voltage to be a certain level, or it doesn't matter? We can do it regardless of the voltage we have on the entering the IGBTs. So here it's 290.
This one you are talking about.
Yes. Does this make a difference to the 500 kilovolts DC or not?
Yeah, this voltage normally they made calculation based on the number of volts and other factors also.
Okay.
Maybe I will give you something in the
Okay.
next check and then give details also. When we discussing about the equipments, we will discuss that. Okay. Okay. Thank you. So
Thank you so much.
we'll see you in next session. Okay.
ان شاء الله. Thank you.